This is Notes 2-1, using graphs to solve systems of equations. A system of equations is a set of two or more equations containing two or more variables. On the graph of the system of two equations, the solution is the set of points where the graphs intersect. A point is a solution to a system of equations if the x and y values of the point make both equations, so I'm going to put an S here, equations true. When solving systems of equations, you're graphically finding the intersections of lines. For two variable, and I'm going to insert a word here, for two variable linear systems, because you can also have a systems of equations that are quadratics, maybe one linear and one quadratic, maybe a linear and an absolute value. Any of the parent functions that we've talked about could be a systems as well. But if you're talking about two linear systems, there are three possible types of solutions. This first solution is when you have one point of intersection, and that would be right here in this example. And so when the lines intersect and there's only one solution, we just say that there's one solution, and then we would write the ordered pair for that solution. So for this particular example, the solution to the system is -2, +1, because that is the point where they intersect. If you have no solution, that means that you have two lines are parallel. So if the lines are parallel, they don't intersect. And so right here it says, in this case, we say there is no solution. So for that particular case, if they're asking you for the solution of the system, you would just write down no solution. Okay, and here's the other thing that could happen. If you have two lines that end up being right on top of each other, okay, so you graph one of them and it looks like this blue line, and then you graph the next one and it is exactly on top of that blue line, then we're going to say that every point is a solution, because every point on those two lines is a solution for the system, because it makes both equations true. So in this case, we say that there are infinitely many solutions. So let's graph this first example to find out where the point of intersection is. So because the first equation is already in slope-intercept form, then what I'm going to do is I'm just going to use my slope, which in this case is the 1/2, and I'm going to use my y-intercept, which in this case is -2, to graph my line. So I'm going to begin at my y-intercept, which is at -2, go up 1 and to the right 2 to get my next point using my slope, and then I can go ahead and I can draw in the line. Okay, now I'm doing the best I can at connecting those 2 points. It's kind of hard when you have this stylus. So let's look at the next equation. So now I'm going to graph this next equation. The next equation is not in slope-intercept form, but I can get it in it real easily by subtracting that x over to the other side. So I'm going to have y equals -x plus 4. So in this case, my slope is -1, which is going to be -1 over 1 if I'm looking at rise over run. My b is going to be 4. So I'm going to begin at 4 on my y-axis, which would be right here. And then I'm going to go down 1 over 1 and keep doing that to get my line. I'll do the best I can at drawing in my line. Oops. Okay. Alright, so if you look at this, it looks like they're probably going to cross at this point right here, because I was off a little bit on my red line, so I think that it will end up crossing right there. But I can check it in my system, so it'd be at 1, 2, 3, 4, 1. So I believe that that's my solution, 4, 1. Let's check it in both of these equations to make sure that it works. So This is going to go in for my x, this is going to go in for my y. So let's check the first one. If I take half of my x value, which is 4, that's 2, and 2 minus 2 is 0. So looks like that's not going to work because it doesn't check out right there. So let's go back to this and let's see if we can pick out where it's going to cross. So what about at 4, 0? And if I was graphing this, you know, with a straight edge and everything, I'd be able to see exactly where it's crossing, but because I'm just having to try and connect my dots as best as possible, let's just try 4, 0. So again, plugging it into this first equation right here, I'm going to take half of my 4, which is 2, and 2 minus 2 is 0. So in that top equation, 4, 0 does work. So let's check it in the bottom one. So my y value is 0, so 0 plus my x value, which is 4. 0 plus 4 is 4. So it does look like it works in both of them, so therefore my answer to this system is 4, 0. So that is my solution to this system. In this next system, number 2, I see that I have a linear system for a linear equation for my first equation. My second equation is a quadratic. So we're going to have to use what we learned from the parent functions on graphing a quadratic to graph the second one. But for this first one, all I need to do is get my y by itself, and then I will have it in slope-intercept form. So I'm going to subtract my 8, which is going to give me 2y equals 4x minus 8, and then I'm going to divide by 2, so I'm going to have y equals 2x minus 4. Okay, so my slope is 2, which is 2 over 1, and my y-intercept is negative 4. So let's graph that first. At negative 4, and then up 2 and over 1 would get my next point, up 2 over 1. And I'm going to try and do a better job connecting these points. I can't promise anything. Alright, looks a little bit better. Okay, now let's graph our quadratic. Okay, in this quadratic, it's just like what we finished doing. It's going to take the parent function of x squared, and it's going to move it to the right 2. Okay. If you want to go ahead and make your table, you can. Some of you might just want to take the parent function and just actually move it to the right 2. But since we've been practicing with the table, let's do that. So at negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. That's the original parent function. And then because it moves to the right 2, I'm going to take my x values and I'm going to add 2 to them. So negative 2 plus 2 is 0, negative 1 plus 2 is 1, 0 plus 2 is 2, 2 plus 1 is 3, and 2 plus 2 is 4. My y values are going to stay the same. So let's go ahead and graph those points. I'm going to graph those in blue. So that's going to be at 0, 4. And then we have 1, 1. And 2, 0. And then 3, 1, I'm getting off the graph a little bit, and then 4, 4. Okay, so we can go ahead and we can draw in our quadratic as best that we can. Okay, and something that I'm going to do is if I was to continue using my slope in my first equation, if I was starting at this point here and I went up 2 over 1, you're going to see that it's going to cross right here at 2, 0. And if you notice that that was one of my points for my quadratic too. So I can already tell that that is one of my solutions, 2, 0. And then if I continue on using my slope for my red equation, I'd go up 2 over 1, so the next point should be here, up 2 over 1, and if you notice that the next point's going to be here. So when I drew my line, it should have gone through right there. This appears to be a point that is on the red line and on the blue line. So that point is 4, 4. So I'm going to write that down here. And now let's check both of these into our original equation. So I'm going to write the checks over here. So I'm going to take 2 times my y value, which is 0, plus 8, and it should equal 4 times my x value, which is 2. So 2 times 0 is 0, 0 plus 8 is 8, and then 4 times 2 is 8, so that does check. Now let's take that 2, 0, and let's plug it into the second equation. So my y, which is 0, is going to equal my x, which is 2, minus 2, and squared. Well, 0 equals 2 minus 2 is 0, 0 squared is 0, so yes, that works. Okay, so this point right here is definitely a solution. And now let's go ahead and check the next one. So if I'm checking the next one, I'm going to take 2 times my y value, which is 4, plus 8, and that should equal 4 times my x value, which is 4. So let's check it. 2 times 4 is 8, 8 plus 8 is 16, and 4 times 4 is 16. So that one checks. Now let's check the next one. So for my y value, I'm going to plug in a 4, and that equals, in parentheses, my x value, which is 4, minus 2, and square it. Okay, 4 minus 2 is 2, 2 squared is 4, and that checks with the 4 over there. So looks like both of these are my solutions. And that's typical when you have a quadratic. You could have 2 solutions, you could have 1 solution, you could have no solution. And if you're doing a linear and a quadratic, you wouldn't have infinitely many, because that would mean that the line would have to match up with the quadratic, and that's not going to happen. Okay, in the next part of your notes, it says steps for solving systems in the graphing calculator. So how we're going to do this is tomorrow when you come to class, in this unit, we will get to use calculators. Yay! So I'll be assigning you a calculator to use in class, a TI-83. And so tomorrow in class, I'm actually going to give you these steps for using a graphing calculator, because I want you to practice using a graphing calculator tomorrow. Most of you know how to graph a line in a calculator, but I'm going to show you how to find the point of intersection using your graphing calculator. Some of you might already know how to do that, but we will work on that tomorrow. Okay, so I'll see you in class.